Today's lesson is covering section 4.5. This is a slope-intercept form. So before you watch this video, you should have watched section 4.4, which talked about the slope, mainly the slope, and then the application of the slope is the rate of change. So we're going to take that information that you learned about the slope, the rise over run, and using the slope formula, and we're going to apply it to a very special equation that we call the slope-intercept form. Now you're going to learn, possibly as early as Algebra 2, that there's different ways to represent a linear equation. But the most common and the most popular way is called the slope-intercept form. And it looks like this. This is what you put in your blank on your notes. It's going to be y is equal to mx plus b. So this is the slope-intercept form generally in its general format. Now, the y and the x are your normal variables, just like, you know, these are probably could be a coordinate of x or a variable value of x. But this m and this b are maybe kind of new to you. Now, the variable m, we know from the last section, your m is always going to represent your slope. So this is your slope times x, and then your b is your y-intercept. And we talked about y-intercepts at the beginning of the chapter. This is the point that actually sits on the y-axis. You're either going to go up or down depending on the sign of your y-intercept. So that's why they call this the slope-intercept form. All you need is this equation to graph your line. So the first thing you have to be able to do is identify your slope and y-intercept in a line. Sometimes they're just going to ask you, can you tell me what the slope is? Can you tell me what the intercept is? Well, if your equation is in this format, that's easy. You just pull it straight out. The coefficient of x is your slope. Whatever that number is, that's your slope. And then whatever your b is, positive or negative, that's your y-intercept. So if you look at example 1, it says, what is the slope and y-intercept of each equation? For example 1, for letter A, I tell you that y is equal to 3x plus 4. Well, you just pull it out. Your slope is positive 3, and your y-intercept is positive 4. And you're done. All I wanted you to do was identify it, and that's what we did. Same thing for letter B. Y is equal to 5x minus 3. So here's my coefficient of x. That's my slope. My y-intercept, you've got to remember, is everything here. It's not just 3. It's whatever sign is in front. So your y-intercept is negative 3. Piece of cake. But look at letter C. Letter C is not in y-intercept form. Now you could try to figure out what the slope and the y-intercept was this way, but more than likely you're going to run into some careless mistakes. So if your equation is not in slope-intercept form, put it in slope-intercept form. And that's simply solving for y. Everything over to the other side, you solve for y, but this time, instead of just throwing everything on the other side of the equal sign, we've got to make sure it's in this format. You have mx, that's your first term, and then your b is the second term. So if I look at my equation, I'm solving for y. The first thing I need to do is move the 3x over. So in order to do that, I have to take the opposite. And I'm going to, well, I'll leave it here because you guys should know by now you cannot combine these two. You should not have 9x on your paper. Cancel. I'm left with negative 3y on the left-hand side, and this is negative 3x plus 12 because I want the x term to be first because it's first in my equation. So no 9x. These are two different terms. You cannot combine them. Now I'm almost done, but I have this negative 3 times y. Got to get rid of the negative 3, which means you divide everything on both sides by negative 3. Now this should not be new. We've been doing this for weeks. You're just solving for y. Y is equal to, well, negative 3 divided by negative 3 is a positive 1. So that's just x. We can put the 1 there because we have to remember that it's there. 12 divided by negative 3 is negative 4. So there's our equation. But I still need to identify the slope and the y-intercept? Well, my slope is 1. And like I said, we can put the 1 there. Even if it's not there, your slope is still 1 because it's invisible. And my y-intercept is -4. So level 1 of any slope-intercept form information, you've got to be able to identify, pull out the slope and the y-intercept. Because from now, if you can pull it out, then you can do a whole lot of other things with it. So we can identify, we can take our equation, we can put it in slope-intercept form, we can pull out our slope and our y-intercept. Now we need to know how to graph using the slope-intercept form. So on your notes, I know you see those steps. You know I like my steps. My steps are guaranteed. Don't make any mistakes with the steps. More than likely you're going to get the answer correct. So before we get to the steps, you've got a little asterisk, double asterisk on your notes there. What I want to put there before we start talking about what you need to do is you've got to pay attention to your equation. If it starts off in slope-intercept form, great. You go proceed on through your steps. But just in case, you've got to make sure that you put the equation in slope-intercept form first. If it's not given to you as y equals mx plus b, you've got to do that first before you follow through my steps, or it's not going to make any sense. So let's assume that you're either given an equation that's in y equals mx plus b form, or you successfully put it in slope-intercept form. Now you start your steps. So here's step 1. The first thing you're going to do is plot the y-intercept. Okay, well, Mrs. Udoka, where's the y-intercept? That's your letter B. Whatever value you have for B, that's where you go on your y-axis, and then you sit there. If it's a positive number, you go up. If it's a negative number, you go down on the y-axis. Then you plot your point. That's your y-intercept. That's the first thing you do. Second thing, you know that you have to have 2 points to make a line. The y-intercept is going to be one of your points. You're going to use the slope to get the second point. So for step 2, you're going to start at the y-intercept. You don't go to the origin. You start at the y-intercept, and you're going to use the slope to plot the second point. Well, how do I use the slope? Well, in the last video, in section 4.4, we talked about 2 different ways to get your slope. The first was with the slope formula, and the second was counting those units and using that rise over run. Since I already have the slope numerically, I don't need the formula, but this rise over run will help me go from my y-intercept to another point on that line. So I'm going to use my rise over run. I'm just going to count the points, the units on my graph, to get the second point. For instance, if my slope is 1/2, that means from the y-intercept, I'm going to go up 1 and to the right 2. This is a positive 1 and a positive 2. So this tells me I rise 1 and I go to the right 2. If my slope was, -3/4, I would start at my y-intercept. The -3 means I go down 3 points, 3 units to the right 4. So wherever you end up after you do your rise and run, that's your second point. So once you get your second point, step 3 is simple. You connect your points and you've got your line. Use a straight edge. Eyeball it, try to make it look like a linear graph, because a linear graph is straight. Connect the points and graph your line. You've got it. So remember, you only need 2 points to graph the line. The first point is going to be the y-intercept. Then we use our rise over run to get the second point. So we'll try a few of these in the next video. How long was that?